All right, so we're going to look at an example using the conservation of energy. And this is going to be really similar to the problems you're going to be doing on the problem set number 2. And the first thing to recognize is we need to pay attention to the steps that we want to use. So we want to underline the variables we know for step 1. 2, draw a picture to help us understand. 3, write the equations we may need. And 4, plug in what we know. Solve for the unknown and write our answer with proper units. So our first example here is that a 500 kilogram pig is standing at the top of a muddy hill. The hill is 100 meters long but has a vertical drop of 30 meters. Unfortunately, the pig slips and begins to slide down the hill. What is the pig's potential energy at the top of the hill? What is the pig's kinetic energy at the bottom of the hill? And what is the pig's velocity at the bottom of the hill? So step 1, we just start by underlining what we know. We know we have a 500 kilogram pig. The hill is 100 meters long. There's a vertical drop of 30 meters. And we have a few things that we need to find. Okay. Step 2 is to draw a picture of what's going on. So we have a pig at the top of the hill. Okay, we know it's 30 meters high, and we want to establish our 0. So I'm going to say that the 0 is at the bottom of the hill. 30 meters is the top of the hill, and we know that the hill is 100 meters long. Okay. Step 3 is to start writing some equations down. We know we have to find the potential energy. We know we need to find the kinetic energy. And we may or may not need this other equation of that the total energy is equal to potential energy plus the kinetic energy. Okay? But it has to be equivalent. Okay? Energy doesn't get destroyed, it only changes form. Okay? So we have the same amount of energy that we start with and the same amount of energy at the end. So we're on to step 4. We want to plug in our variables, solve for the unknown, and write our answer. So let's just start by solving that first problem. What is the pig's potential energy at the top of the hill? So we write our potential energy equation of PE, or potential energy, equals mass times gravity times height. And if you don't know the gravity by heart, that's fine. I'm always going to give you that constant. We know it's 9.8 meters per second squared. Okay, so we can use that information then to help us out. So we know the mass of the pig is 500 kilograms since we underlined that in the problem. Gravity is 9.8 meters per second squared. And the height is 30 meters. And we have to be careful here because we don't want to use the 100 meters since that really doesn't tell us the height. That's just the length of the hill. We are only concerned with how high this pig is off the ground. So if he starts at 30 meters above the ground, he's going down to 0. We know that's how high he is. Okay, so then it's just a matter of calculating that out. So the potential energy is equal to 147,000. And then we have that crazy unit of kilogram meters squared per second squared. However, we have a shortcut for this, and we can call that joules. Okay, with a capital J, and that's how we can shortcut that unit. So that's why we have the energy can be measured in joules. This is where this is coming from. All right, so we have our total potential energy is just 147,000 joules. And we're not done because now we have to calculate the kinetic energy at the bottom of the hill. So we have our kinetic energy equation. And if we plug in what we know the mass, but we don't know the velocity. Okay, and if we, All right, and how can we find the kinetic energy if we don't know the velocity? We just have too many unknowns. So we can use this other equation to help us out. If the total energy in the system is equal to the potential plus the kinetic energy, okay, so the kinetic or the total energy at the top has to be equal to the total energy at the bottom. At the bottom, we would have to assume that there's no potential energy. The bottom of the hill is 0 meters. So if we were to take the mass times the gravity times height, if height is 0, the whole thing would be 0. Potential energy would be 0 at the bottom of the hill. So when it's the top, we assume there's no kinetic because the pig isn't moving. He just kind of falls down the hill. Okay, he's not pushed, he just slips. So our total energy is equal to potential plus kinetic. So we have the potential at the top, this kinetic at the top equals potential plus kinetic at the bottom. We fill in what we know. We know the potential energy at the top is 147,000 joules. We figured that out in the last problem. The kinetic energy is 0 because he's not moving. The potential at the bottom is 0, and we don't know what the kinetic energy is at the bottom. We're trying to figure that out right now. All right, so therefore, when we add everything up, what we're left with, we just have 147,000 joules equals the kinetic energy at the bottom. We don't even have to calculate anything for this one. Okay, the potential at the top is equal to the kinetic at the bottom. Okay, it's all transformed into kinetic energy. So we have one last thing to find. We need to get the velocity at the bottom of the hill. And this is where we can now use our kinetic energy equation because we know the kinetic energy, we know the mass, and all we have left to do is find what the velocity would be. So we plug everything in that we know. Okay, so I'm going to zoom in here. So we have 147,000 equals 250 kilograms, because I took half of 500, times velocity squared. And that velocity is the only thing getting squared. Not the mass, not the 1/2, just the velocity. Okay, so we want to divide by 250 on each side, because that'll cancel out the 250 on the right side of the equation with the velocity, and we can get velocity by itself. Okay, so then we're left with v squared equals, and then if I take 147,000 divided by 250, I end up with 588 meters squared per second squared. If I square root each side, I get 24.2 meters per second equals the velocity. Okay. And that's all there is to it. Now it seems like there's a lot here and a lot of work, but I've shown you a lot of stuff that you wouldn't need to write down, okay, especially right here. This is stuff that you're not going to have to write down when you do this yourself. Okay, but the main thing is recognizing, what we need to find first, or what we can find first, okay, and using everything that we know about the problem to help us out. Okay, so this will be really helpful as you start working on the problem set number 2. And there's also going to be a Khan Academy video that will help you out in terms of what happens when you're in the middle of the hill. Right. So, and that'll be really helpful with the roller coaster problem on the problem set 2. So good luck, and if you have any questions, you can always ask.